Okay, so so this is the MATLAB program we have written previous week. Okay, so maybe you haven't completely understood the things here. Okay, so anyway, I will explain quickly. Okay, so here we need to generate a sinusoidal signal first. Okay, using this MATLAB program, first we need to generate a sinusoidal signal. Okay, so you know. So signal is a graph. No? Signal has two variable. One is independent variable and other one is a dependent variable. Okay. So signal can be represented as a graph. Okay. So you know how to draw graph. Okay. So first you set some value for independent variable. Then using the equation, you calculate the corresponding amplitudes value of the dependent variable y-axis parameter. Then you mark independent variable. Then you mark the dependent variable, corresponding dependent variable values. Okay. Then you join the point. Okay. So that is the normal way to draw a graph. Okay. So the MATLAB also doing the same things. Okay. So these two command, first two command, we use to clear the workspace content. Okay. And the content in command window. Okay, this CLC and clear all. Okay. Then this is this is a time domain signal. Okay, so we draw a time domain signal. This is a sinusoidal signal. This is a signal we have drawn. Okay, to 5 ft. Okay, xt is equal to cos 5 ft. Okay. So the amplitude is 1 here, okay, and the frequency is 50 hertz, okay. This signal, okay. So so this is a time domain signal. So you first set the time value, some values for times, okay. So it is from 0 to 0.2, okay. So when you are selecting this time range, you need to be careful, okay. Because for example, this signal is a 50 hertz signal. Okay. So what is a one cycle value, one cycle time? If this is 50 hertz, what is the time for one cycle? Please tell me. This is number of cycle per second. Then what is the time for one cycle? Please tell me. Frequency 50 hertz now. එයාගේ period එක එහෙම නැත්නම් one cycle එක time එක. We also called it period, fundamental period. Okay. So what is the time for one cycle? 50 hertz. That is number of cycles per second. Cycle per 1 second. Then what is the one cycle value? One cycle time?
0.02.
Yes, that is 1 divided by 50. So it will be 0.02. Yes. So this is one cycle time, 0.02. Okay. So when you draw a signal, so the signal is like this, no? And cosine signal is like this. Signal like a one. Right? So when you draw, so this one cycle, this is one cycle. Okay. So this time is 0.02 second. Okay. So so when you are selecting this time, okay, so this time gap, the gap should be very much small to this 0.02 second. Okay, because you need at least some points here. Okay, to get a smooth graph. Okay, so this the selected time values. Okay, so we are selecting some time values now, 0 to some value. Okay, so this time value uh, should be should not be the difference of these values should not be higher. Okay, so it should be very low value. The difference of the consecutive points should be very low. Okay, so that is why we use this increment, that is 0.001. So it is very much lower than this 0.02. Okay. And when you are selecting the final value, so you can see that if you select in the higher value, that means so our screen is somewhat low. No, we have a limit for our screen. Okay, so in that screen, several cycles will be drawn. Okay, so that we couldn't see the cycle very clearly. Okay, so here we have select only 10 cycle. Okay, 10 cycle. So one cycle time is 0.02. So 10 cycle value will be 0.02. Okay. So here we only we try to draw only 10 cycles. Okay. So so what I want to tell you is that when you select in this beginning value, end value, and the increment, you should be careful. Okay. So otherwise signal will be not shown proper. Okay. If you are selecting some improper value, we can't see the signal very well. Okay. So that is one. That is what you should need to careful. Need to be careful. හරි තේරුණාද කියපේ? දැන් මෙතන 0.02නේ 0.02ක් එයාගේ cycle time එක. එක cycle එක time එක. හරි. එතකොට අපි සාමාන්‍ය graph එකක් අඳිනකොට මෙන්න මේ cycle එක ඇඳෙන්න ඕන. නැත්තම් බෑ. හරි. දැන් අපි මේ හරියෙන් point එකක් අරගෙන මේ හරියෙන් point ඔය වගේ select කරලා මේක අඳින්න ගියොත් එහෙම මේ හැඩෙන්නේ නැහැ. එතකොට අපි අඩුම තරමේ මෙන්න මේ විදිහට යම්කිසි point ටිකක් mark කරගන්න ඕනේ. point 10ක්වත් අඩුම තරමේ. 0.02 අතර point 10ක්වත් calculate කරලා ඒ ටික යා කරගන්න ඕනේ. හරි. එතකොට අපිට මේ ඒ calculate කරගන්න point අතර ඒ කියන්නේ ලොකු gap එකක් තියෙන්න බෑ. The gap should be very small. Okay. හරි. ඒ විදිහට select කරගන්න ඕනේ. Okay. Otherwise the signal will not will not be drawn properly. Okay. And also when you are selecting this final value, the range of time, හරි මේ time එක මේ final value එක select කරගන්නකොට මෙතන පොඩි cycle ගානකට, ඒ කියන්නේ cycle 10ක් 15ක් 5ක් ඒ වගේ ගානකට ගැලපෙන විදිහට තමයි මෙතන final time එක select කරගන්නේ. හරි. එතකොට ඒ ටික ගැන ඔකට පොඩ්ඩක් සැලකිලිමත් වෙන්න ඕන මේ time value එක select කරගන්න. signal එක අඳින්න time value එක select කරගන්නකොට ඒක ඔකට පොඩ්ඩක් මේවා කරගන්න. හරි. ඊට පස්සේ අපි කෙලින්ම we can so once you select the time values, you can write the equation for the signal. Okay, so this is our signal. Okay, so you have to use this bracket and this multiplication sign when you are writing multiplication, and the mathematical operators you have to apply when you are writing the equation. Okay, so you have write the equation, then basically we can use 3 command to draw. Okay, 3 command to draw a signal or graph, that is scatter command. Okay, scatter command and plot command. Okay, plot we use to draw continuous time, continuous variable, continuous time signal. continuous time signal, and other one is system. The system command we use to draw discrete time signal. Okay, DT discrete time signal. Okay, so three plotting commands we have in MATLAB. Okay, scatter, plot, stem. The plot we use to draw the continuous time shape signal. Stem command we use to draw discrete time shape signal. Okay, and scatter command, if you use scatter command, you can see the point corresponding uh, y point, y-axis point, or dependent variable points on it. Okay, so this command you can use. Okay, so here we have first use plot command because we need to draw this. We need to draw this signal, continuous time signal. This is a continuous time signal. So we use plot command. Okay, so when you are using plot command, so within bracket you need to first write the independent variable, then dependent variable. Dependent variable is x2t. Okay, so once you run this, okay, so you can see that we can get this kind of graph. Okay, actually this we can only see this blue line graph. Okay, blue line graph, that is our continuous time signal, and we draw it using this plot command. Okay, for example, if I comment this all these things, okay, if I comment all these things, you can right click here, then comment. Okay, then these commands will not be executed. Okay, okay, so you can see that this is a continuous time sinusoidal signal. Okay, so if you um, increase this uh, time, okay, increase this time, the ending point time, that means number of cycles will be increased. Okay, number of cycle will be increased. Sorry, 0. Not 1, 0.1, not 0.11. Okay, so you can see that number of cycle will increase. Okay, that means there are around 50 cycles. Okay, within this scale. Okay, so you can't see the cycles clearly. Okay, so your graph will not be clear. Okay, so that is why I asked you to draw some appropriate number of cycles. Okay, so according to that, you need to select this final value. Okay, so we use 0.2, that is 10 cycle value. Okay, like this. Okay, and if you reduce this increment, okay, if you reduce this increment, again you can see that you can get this kind of uh, line. Okay, because it calculates the values at 0.1, 0.1, 0.2, 0.3, 0.5. All these are equal to 1. Okay, so you will get this kind of signal. Okay, so it is not a sinusoidal signal. Okay, so you have to properly select this increment. Okay, if this increment is very low, that will be very good. Okay, but if you if you if you select in very low value, okay, so number of calculating points also increase. No? Okay, if you calculate this value, okay, you can see now there are 20,000 value. Okay, that means you have to calculate 20,000 value. X2t also 20,000 value you have to calculate. Okay, so it will get some time. Okay, so it is better to select some appropriate value. Okay, so if I use this one like this, so maybe only 2,000 values are there. Okay, so that is enough. Okay. So when you are selecting this time points, you should think all the things. Okay, So you can select very near point, but if you select very near point, the gap is getting low, the number of samples, number of points you should calculate will be higher. Okay. So that is also one disadvantage. Okay. 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 So that is how we generate the sinusoidal signal. Okay. So this up to this level, we see how to generate the signal. Okay. Then from here, we sample. Okay. This is here we try to sample the signal. Okay. From here, sampling process. Okay. Sampling process. Okay. So we have one comment. Okay. We have one comment. Okay. Now all this command will be executed. Okay. So first we select the number of samples, sample number in. Okay. Then sample frequency fs. Okay. And so if the sample frequency is fs, you know the sample time is 1 over fs. Okay. And you know the corresponding sampling time, the sample, the corresponding time for sample is NTS. We have discussed these things. Okay. So this is corresponding time for one sample. Okay, this is corresponding time for one sample. Sorry, n sample. Nth sample. Corresponding time for n sample. n many sample එකට අදාළ time value එක තමයි මේ TS එකෙන් දෙන්නේ. Okay. Then we draw the discrete time signal. Okay, you know that discrete time signal should be drawn with respect to n. Okay, it is a function of n sample number. Okay, discrete time signal. Okay, we already discussed this thing. Discrete time signal. Okay, signal is a function of n. Is a function of n. Okay, so we write that equation. So what you have to do is that instead of this t, okay, you can apply the corresponding sample value, that is in sample time, corresponding sample time, that is NTS. Okay, so TS is equal to 1 over Fs. Okay, so if you put 1 over Fs here, so it will be F divided by Fs. So that is we call the normalized frequency. Okay, normalized frequency. Okay. Then this is the hold on command we use. Okay, because we need to draw this continuous time signal, and this stem we used for discrete time signal to draw the discrete time signal, and we need both graph in one both signal in one graph. හරි, මේ signal දෙකම එක graph එකේ එන්න ඕනේ. ඒකින්ද තමයි මෙතන hold on කියන command එක දැම්මේ. එතකොට මෙයා ලියවිලා මෙයා ඇඳිලා ඊට පස්සේ ඒ data තියද්දිම මෙයා ඇඳෙනවා. Okay, otherwise if you delete this hold on command, first it draw this one, but once it draw stem, the first this value will be deleted. Okay, this graph value will be deleted. Okay, so we can see only this one. Okay, so if you need to put both these plotting, both these graph, both these signal plot and stem graph, you need to put hold on command. Okay, so likewise you use stem. Okay, so when you are draw this discrete time signal, okay, we normally draw it with respect to n sample number, 0th sample number, 1 first sample number, second sample number. Okay, but now you are going to draw this signal with respect to time actually. Okay, with respect to time. Okay, so this time is a second value, and this n is some number, integer number. Okay, so we have a mapping there. Okay, actually this is the mapping equation for that. Okay, okay, so when you draw the signal, you have to use corresponding time value, because this plot also doing plotting with respect to time. Okay, so this one also should be with respect to time, the corresponding time value of a of the signal. Okay, so I asked you to use, let's say that if we use 25 hertz, 25 hertz sampling frequency. Okay, so I use 25 hertz sampling frequency. Okay, so that is the half of our sampled sampling signal. Okay, so you can see that we get a zero sample here, first sample here, second sample here, third sample here, fourth sample here, sixth sample here, so on. හරි අපිට මේ විදිහට එන්නේ සිග්නල් sample ටික. හරි හරි zero sample, first sample, second, third, fourth, fifth sample. Okay, so we get the sample like this. Okay, so we get one sample and we get another sample like this. Okay, so now if I ask you to draw this signal, you should be able to draw. So what you have to do, that how you draw it. So this is the sampling frequency. So if you know the sampling frequency, you can calculate the sampling time. So sampling time is 0.04. Okay, so first sample you get here, then the next sample you get after 0.04 time. හරි එමුණ කට්ටිය sample එක අඳින්නේ නේ. දැන් ඒක ඔය කට්ටියට කියනකොට ඔළුවට එන්න ඕන. හරි දැන් අපි මේක ගොඩාක් කරලානේ තියෙන්නේ. දැන් අදින් මේ sampling එක නවත්තන්න ඕන. We need to stop the sampling from today. Okay, so you need to I didn't understand this. මේක පුළුවන් තරම් හොඳට understand කරගන්න. හරි so you can see that the time value, the x value 0.04. Okay, so this is the first sample. Again here that is 0.08. that means again after 0.04 value නේ. ඉස්සෙල්ලාම බිඳුවේදී ගන්නවා, ඊළඟට 0.04 දී ගන්නවා, ඊළඟට 0.08 දී ගන්නවා, ඊළඟට 0.1 2 දී ගන්නවා. ඒ කියන්නේ 0.4කට පස්සේ 0.04කට පස්සේ ආපහු 0.04කට පස්සේ ගන්නවා. ඔය විදිහට සාම්පල් ගන්නවා. එතකොට සාම්පල් එන්න මේ විදිහට. මෙතන එකක් එනවා, මෙතන එකක් එනවා. මේ විදිහට තමයි සාම්පල් එන්නේ. හරි. හරි. මට දැන් කවුරු හරි කියන්න බලන්න. Tell me what is the normalized frequency of this discrete time signal, sampled signal. So this is the sampled signal. Okay, so can anyone tell me what is the normalized frequency of this discrete time signal? Okay, so what I am asking, okay, so we have continuous time signal, that is cos 2550t. Okay, so this is our continuous time signal. Okay, now we use sampling frequency to 25 hertz. Okay, then we sample this signal. We sample this signal by this hertz, by this sampling frequency. That means xt is sampled within 25 hertz. 25 hertz means sampling time will be 0.04. That is 1/25. Okay, then once you sample the signal, okay, so you will have this kind of signal. So first sample you get here, second sample you get sometime, third sample, so on you will get. Okay, so these are the sample you get. Okay, so this is 0 sample, 1 sample, second sample, like this. So you put here's the sample number n. Okay, and your signal will be the function of x sample number. Okay, so finally that means your discrete time signal will be a function of n, xn. Okay, so if you want to find this xn, what you have to do is, so you have cos 2550t. Okay, instead of this T, you can put NTS. Okay. So TS is equal to 1 over Fs. That means Fs is equal to 1 over Ts or something. Okay. So Ts is equal to 1 over Fs. So if you put here 1 over Fs, it is like this. This is called the normalized frequency. This is called the normalized frequency of the sampled signal or discrete time signal. හරි. මෙන්න මේකට තමයි අපි normalized frequency එක කියලා කියන්නේ. හරි. එතකොට මට කියන්න 25 Hz නම් select කරගත්තේ. මෙයාගේ normalized frequency එක කීයද? sampling frequency එක මේ fs කියන එක 25 නම් මෙයාගේ normalized frequency එක කීයද? එයාගේ normalized frequency එක කීයද එතකොට? මේ xn ගේ normalized frequency එක කීයද? fs කියන එක 25 නම්. normalized frequency එක කිව්වේ මොකක්ද අපි? මේ TS එනකොට NTS දානවා. එතකොට TS කියන්නේ එකයට fs. හරි? එතකොට මෙතන TS වෙනකොට එකයට fs ආදේශ කරනවා. එතකොට අපිට මේක මේ පැත්තට fs කියන එක මේ 50ට ගත්තොත් 50 බෙදීම fs කියලා ගත්තා හැකි. හරි? එතකොට මෙයා මෙන්න මෙතන මෙයා මේක තමයි දැන් මේක 25fn. හරි? එතකොට මේක තමයි discrete time signal එකේ frequency එක. හරි? ඒකට අපි කියනවා normalized frequency එක කියලා. හේතුව තමයි ඒක හැම වෙලාවෙම sampling frequency එකත් එක්ක depend වෙනවා. හරි? ඒක එන්නේ 50 බෙදීම sampling frequency. ඒකෙන් හින්දා තමයි ඒක normalized frequency එක කියලා කියන්නේ. හරි? දැන් එතකොට මෙයාගේ sampling frequency එක 25 Hz. normalized frequency එක කීයද? එහෙනම් normalized frequency එක කීයද? පනහ බෙදීම fs 50 බෙදීම 25 කියන්නේ දෙකයි නේ මෙයාගේ normalized frequency එක කියන්නේ දෙකයි හරි normalized frequency එක දෙකයි හරි normalized frequency එක දෙකයි කියන්නේ හරි කයට දෙක ඒ කියන්නේ period එක frequency එක එකයට frequency එක ගත්තාම period එක නෙන්නේ එකයට fs එකයට f කියන්නේ එයාගේ fundamental period එක නේ හරි එතකොට මේක තමයි period එක නේ half period Okay.